Okay, this is question 13 from optimization. Okay, so we have train A, and it leaves the station at 10 a.m. and travels south. It's traveling at a speed of 65 kilometers per hour. Then we have another train, train B, let's call it. It's heading towards the station that A left from. And it arrives at the station at 11 a.m. And it's traveling at 45 kilometers per hour. So the first thing I want to do is set up some equations. So I'm looking for distance because I want I'm trying to find when the two trains are closest to each other. So I'm looking for, as train B is traveling along this track and train A is going this direction, I'm looking for this is the distance that I'm trying to minimize. The distance between them, if this train's here, this train's gonna be back here. I'm looking for what is the shortest distance. So I have a feeling Pythagorean theorem is gonna be involved. Okay, so for the A train, I'm gonna represent, I know that distance is equal to speed times time. So I'm gonna write train A. I'm gonna assume that's the origin, and I'm gonna say this train's traveling at 60 t. 60 times time. So at time 0, 60 times 0 is 0. So it's right at the origin. After an hour, it's 60 kilometers away, etc. Okay, so I got an equation for that, for distance. For the blue one, it's a little trickier. But generally, at 10 a.m., the blue train is going to be 45 kilometers away, right? Because it's traveling at 45 kilometers per hour. So at 10 a.m., since it takes an hour to get to the train station, at 10 a.m., it's going to be a total of 45 kilometers away. So that's 45 kilometers. Now, I don't know how far it's going to get when they're actually the closest to each other. But I do know that, as it's traveling, it's going to be traveling at a speed of 45 kilometers times time. So the distance is 45 t, but I'm looking for this distance, whatever it is, that, or is it going to be like that? I don't know what the size of it's going to be, but I'm looking for 45 minus 45 t. So I'm looking for that distance, and the reason is it's starting 45 kilometers away from the station. So that's kind of our initial value. It's at 45. And then it's heading in a different direction than this train. So I made it negative 45 t for its speed distance. Okay, I'm recording a video. Okay. So these are my two equations for distance. And I'm trying to minimize the distance between them. Okay, so I need to do Pythagorean theorem to figure out the length of that line. So the distance of that line, I want it to be the smallest. So Pythagorean theorem is I just square both sides and add them. So 60t squared plus 45 minus 45t squared, add them, and then I square rooted it. So that's the equation for that distance, and we want that to be minimized. I'm going to change my square root to actually be to the power of a half for my derivative calculating. So my next step is going to be to find the derivative. So let's say I wrote that as d of t. So prime d prime t. Calculate the derivative of that, set the derivative equal to 0, and that will tell me the time when the trains are closest together. And then I can sub time back in if I want to know the shortest distance. So I'll finish the rest of this in class. But that's how you set it up, and then you just have to find the derivative. Hope that helps.